Here we have the paper ImageNet, a large-scale hierarchical image database. This paper appeared at the IEEE Conference on Computer Vision and Pattern Recognition, CVPR, in 2009. The paper describes the ImageNet database, which is a set of images that are annotated with concepts belonging to the WordNet ontology. You would want to read this paper if you wanted to know more about the ImageNet dataset, related datasets, possible applications of the ImageNet dataset. But our main interest here in this video is how the ImageNet dataset was created, which was by using crowdsourcing, in particular Mechanical Turk. So first I'm going to talk a little bit more about the ImageNet dataset, then we'll talk about how it was created using crowdsourcing, and finally we'll turn to look at some Mechanical Turk results concerning labeling of images. Okay, so ImageNet uses a hierarchical structure of WordNet, and here is the WordNet website. WordNet is a large lexical database of English, and the entries in this database are grouped in sets of cognitive synonyms, which are referred to as synsets. And each of these sets of words or phrases expresses a distinct concept. So likewise, in the ImageNet dataset, we're going to have synsets that consist of images that depict the same concept. Here they're telling us that in this paper 12 subtrees are investigated, and these are listed here. So mammal, vehicle, fruit, musical instrument. So let's see how that works. We'll go here to the ImageNet website and let's type in musical instrument and see what we get. Okay, so here we see the synset for musical instruments. We click in, and unsurprisingly we get a set of images that deal with musical instruments. Now here we can see the ImageNet hierarchy. So musical instrument is a device. Here we go. And a device is a instrument, and an instrument is an artifact. An artifact is part of the mother node ImageNet 2011. Now the musical instrument as a concept has its own hyponyms. Here we see stringed instruments, percussion instruments, wind instruments, and keyboard instruments. So we can click in here and take a look at the string instruments, and these break down again into a set of hyponyms: bowed, piano, chordophone, etc. So these are very nice sets of images. We notice here that there's some perhaps less widely known stringed instruments, so that's very interesting. Okay, returning to the paper. What ImageNet is intended to do is to serve as a resource for visual recognition applications, object recognition, image classification, and object localization. Since 2009, there's been a lot of interesting papers on these areas. Now I'm going to go over briefly the properties of ImageNet. So ImageNet aims at scale. So they want to be the most comprehensive and diverse image set in the world. Here they say the most comprehensive and diverse coverage of the image world. So we probably need a little bit of a caveat there. Let's return to ImageNet and see. Okay, so we look for something else. For example, it rains a lot. Let's look for rain. Now, rain is giving us not what we imagine pictures of rain, but rather synsets that contain the word rain in them: rain stick, rain barrel, Okay, so that really doesn't work too well. Recently we had Thanksgiving, pictures of Thanksgiving. Well, we have this flower which is called the Thanksgiving cactus. Princeton is in New Jersey. New Jersey, okay, that didn't really work at all. So we can see when they claim to be comprehensively covering the image world, it's a specific image world. It's a world of images that depict specific entities, okay? So let's remember that maybe we want to define the image world as being larger than what is covered by ImageNet. But ImageNet is, of course, great. Here we see some examples. Again, husky, which is a hyponym of working dog, which is a hyponym of dog, which is a hyponym of canine, which is a hyponym of carnivore, and so forth. That gives us a really clear illustration of the structure of the thing. Here, this is what they mention here, the hierarchy. They would like to very densely populate this hierarchical structure of categories. Also, they would like to give a very high accuracy, and in addition to accuracy, diversity. So basically the goal is that the images should have variable appearances, the positions of the objects should be different, here they have to scroll down, different viewpoints, poses, and different sorts of background clutter and occlusions. Okay, so those are the basic characteristics of ImageNet. Let's go on to look at exactly how this was created. So as I mentioned before, the ImageNet dataset was constructed using crowdsourcing. So first, they collect candidate images from the internet by querying several different image search engines. Okay, and once they have those candidates, they need to clean them. And in order to clean them, they use human computation power from Amazon Mechanical Turk. So basically, this is what the human intelligence task looks like. The workers are presented with a set of candidate images and a definition of the target synset, which includes a link to Wikipedia. And they're asked to verify whether each image contains the objects of the synset. And here is how they get the diversity, by encouraging the workers to select the image even though there might be an occlusion, there might be a number of other objects and or clutter in the scene. Okay, so now what they note about this verification task of the concept labels is that some labels are relatively more difficult to assign than others. Let's have a look at this diagram here, because this really shows what the issue is. So there's these three images. They're small, but they're cat images here, and then they give the responses of a number of different workers on the Amazon Mechanical Turk platform. You see they don't agree about the images. And the point is here is that when you ask, does that image contain a cat, then it's pretty easy to get agreement on the platform and to get a good, clean label. But if you ask, is this a Burmese cat, there will be less agreement, and you'll need more labels from more workers in order to get a good, clean label. And what they've done is that they've used several images to come up with a confidence threshold. So this is the confidence threshold that they need to pass in order to be sure that they have been able to successfully label a given image with cat, or in this case with Burmese cat. Okay, so we see that if they get, for example, 2 yeses and 0 nos on a given image, their confidence that the image does contain a cat is at 0.97, but it's relatively lower, 0.83, that image contains a Burmese cat. Okay, and well, why is this? They say more votes are needed to reach the same degree of confidence for a Burmese cat. And let's talk about exactly what the problem is with Burmese cats. So users don't always agree with each other, and they say that Burmese cat is relatively more difficult label to assign. However, when we take a closer look at what Burmese cats are, let's go to the Wikipedia page, we see that Wikipedia actually tells us that different associations have different rules by which cats count as Burmese. So in a way, they are pushing the problem onto a crowd that might be a problem of rather ill definition of what a Burmese cat is in the first place. Okay, so then you have the question of how do you make these decisions? Which association is the one that gets to tell what a Burmese cat is, and how do you teach crowdsourcing workers how to apply the correct Burmese cat rules? It becomes very, very difficult. So basically, in order to try to get a more clear view on the difficulty of collecting labels from about images, I want to turn to some other results that we have gotten in a project. So this ends my discussion of ImageNet, and we continue talking about image annotation, but with respect to a different project. So the project that I'm going to talk about is the Kubrick Project, which is dedicated to creating a toolkit which will allow the implementation of search algorithms which combine machine and human annotations. Okay, so this is not the only goal of Kubrick, but this is the one that's relevant here. We want to create basically search with a human touch, as we say, integrate crowdsourcing into multimedia search engines. Okay, so much for the project pitch. What we have done within Kubrick is we've collected annotations on Mechanical Turk, and this interface was implemented by one of the Kubrick partners, Innovation Engineering, and we're really happy about this because this allows us to visualize the results of multiple crowdsourcing workers for a given image. Here we are looking at an image of a handbag, and we'll go and look to see what different workers on Mechanical Turk have told us about this handbag. First of all, they've given their genders here, their ages. We have one from Chile, one from the US, one from India. They all agree that this is a handbag. They confirm that label. Here, this one deviates slightly in selecting that label, and instead would prefer to call it a purse. Okay. They all agree that this is an item that is related to fashion. Here we're asking them something slightly different. Would you use this image in your fashion blog? This gets at some other aspects of this image, namely whether or not people find it appealing and interesting. And these aspects are revealed by what they report would be the title of that blog entry. Knit your own purse, go crochet handbag. And on the basis of this, then they go and they say, okay, do you like that picture or not? It's ugly. It's love the pink color. The color combination is nice. Okay, so what we see here is a response of highly objective categories. This is a handbag, ranging up into a response of do you like this or not, and why? And we have pretty solid answers from all three of these workers on all counts. In the remainder of the video, I'm going to show you the way that we put together this hit for publication on Mechanical Turk, so that you have a bit of understanding of how to design a hit like this. So the question might be, well, why are you doing this if you already have ImageNet? One of the problems with ImageNet is that the images cannot be freely used. They might fall under copyright restrictions, and we're developing a data set that is has Creative Commons images in it, so it can be freely used for research purposes. Here we are on Amazon Mechanical Turk, and I'm going to give you a quick overview of how one goes about designing a HIT or a human intelligence task that can be used to collect or validate image labels. So here we are in the interface, and we are under the tab Create. So this is where you create a new project, but in this case I'm editing an existing project just to speed things along here. Okay, so we've given the project a name, which is used for internal management purposes, and then we go on to the description that is seen by the workers. We've put a title here. Okay, select images of clothing items and fashion accessories. So the purpose of this HIT is to confirm whether a given label is relevant to an image that contains clothing item or a fashion accessory. We've added a description and keywords. So these should be maximally informative, but also should be kind of interesting. For example, we haven't said labeling or verifying or anything like that. We emphasize the content of the images, which is clothing items and fashion accessories. We're providing a reward of 5 cents per hit. For each of the sets of images, we have 3 separate workers who will be working on them. This is the number of assignments per hit. They're allowed a maximum of 10 minutes to complete the assignment, and the hit will be available for 7 days, and we promise that we'll automatically we'll approve the hit within 10 days. If we don't act, then it gets automatically approved and the workers get paid. Okay, next we move to design layout. Okay, so here we have just an editing interface in which we can create a layout design for the hit. You should see that we have variables which will be then filled in when the hit is published. And we start out by saying that we are a nonprofit project, and that allows people to understand the context in which we're doing this, that we're not a commercial organization. And we first ask about the image category. That would be, for example, cowboy hat, and then we say, how familiar are you with cowboy hat? And they can tell us how familiar they are. We do a little bit of on-the-spot training by giving them an image and a definition from Wikipedia. That definition gets substituted here in the variable. And then you have to imagine that there's also a picture here from Wikipedia which appears. And then we ask them questions about 4 images. Okay, again, because this is the editing interface, you don't see the images. These are added later because there's different images for each hit, but you can imagine that they're there. So we ask them about cowboy hat for this picture. First of all, yes, it contains a cowboy hat, no it doesn't, or it's I am not sure. And then we ask if the image is fashion related at all. So we do have a lot of noise in our set. The image might be of something completely unrelated to clothing and fashion items. Now these 2 questions are used to reconfirm each other. So if they say that yes, it does contain a cowboy hat, we do expect that you would answer yes, the image is fashion related. It's not all cases will it be really the case that that these questions match up. So we use mismatches then to flag the responses of the workers, and then we go in and examine those responses by hand. We finish here by asking people if they're interested in doing more of these hits. In this way, we can use this particular hit as a recruitment step to find people who are good at doing this, who like doing this, to invite them for further hits in the future. We also ask them to give us feedback on the hit. There's some workers that are incredibly insightful about how to change the design to make it easier. For example, eliminate scrolling or make it more fun. So this suggestion box is very helpful. Okay, so when we're finished designing, we do preview, and then what we would do is we would finish, which would take us back to the overview of all of our hits available, and then we can select new batch, which is what we need to do in order to publish. After we've selected that, then we specify the file that gives the material that gets filled in for all the variables, and then we can click to put it online.